Welcome, everybody. We've done a lot of hard work at this conference over the past 2 days. I think we've made a lot of progress on some important issues. I'm looking forward to a lot of momentum coming out of this conference. I'm tempted to say we've saved the best for last in the form of our closing keynote address by Dr. Walker from DARPA. But I don't mean that in any way to demean the quality of what has been presented at this conference so far. I'm not an unbiased witness by any means, but trying to be as objective an observer as I can be. I think this has been an uncommonly high-quality conversation we've had over the past couple of days, and I'm personally very gratified. And I want to express my own thanks to everyone who traveled some distance in some cases, including red-eye flights from the West Coast to be with us. We're very, very grateful for all that you've brought to this meeting. But to our final event. It is my sincere pleasure, my great pleasure, to be introducing Dr. Stephen Walker, the Deputy Director of DARPA, as our concluding speaker. This is one of those occasions where it's true to say, when I say that for many, if not most of the people in the room, Dr. Walker hardly needs any introduction. But let me give just a little bit of an introduction and stage setting. So again, Dr. Walker is currently the Deputy Director of DARPA. He has come to this point in his career after a long period of service, for the most part in the early years in the Air Force scientific and technical research arena, with postings at a number of different research facilities along the way. Including one at Wright-Patt, which is not too far from where I grew up. I think of it as my hometown Air Force Base, if that makes any sense. Immediately before taking on his responsibilities as Deputy Director at DARPA, he served for a while as the Director of the Tactical Technology Office at DARPA. But all of this doesn't matter. What matters to me is that just as we started our conference with an opening keynote lecture by General Lattiff, whom some of you will remember my having introduced as a triple domer, that is someone with 3 degrees from Notre Dame, I am immensely proud of the fact that Dr. Walker is a double domer with a bachelor's degree and a PhD from Notre Dame. And if I might editorialize for just a moment, I find it interesting that important thought leaders in the weapons development and research community who distinguish themselves by the depth and sincerity of their own personal engagement with ethical, legal, societal impact issues in this arena have this Notre Dame pedigree. I choose to believe that all that we say to our students here about the importance of thinking about the value dimensions of human experience, I like to think that that has an impact, and I think that in the persons of both General Lattiff and Dr. Walker, we have living examples of what a hugely valuable difference that engagement with values can make over one's career. And not just by way of making you a good person, but by opening up all sorts of pathways for your careers that might not otherwise have been available. But with that, let me turn the floor over to Dr. Walker, who is going to be talking to us under the provocative title that I love, DARPA, 56 Years of Creating and Preventing Technological Surprise and Why That Matters to Our Society. So please join me in welcoming Steve. Here we go.
Great, thank you. I attribute my interest in ELSI to the 2 mandatory semesters in philosophy that I had to take. Yeah. engineers and scientists still have to do that here?
Oh, yes.
Okay, good. No, I think it's fantastic. 2 semesters of philosophy, 2 semesters of theology. Goes a long way. But finally, after 2 days, the engineers get to respond. So that's what I'm here to do. Yeah. It shouldn't be that provocative a talk, but I am going to actually, Shannon was a great setup, because I am going to try and answer what DARPA is good for, actually, and organizations and agencies like DARPA in the government. I'll speak a lot about what we do and why we do it. But I want to thank the Notre Dame Reilly Center first, Notre Dame School of Law, Kroc Institute for International Peace Studies, and the Notre Dame International Security Program for hosting and organizing the symposium, and thanks to all the people who worked so hard to make it happen, and who worked on the National Academy's report, I guess, or I know, instigated this symposium, and thanks to Herb especially for getting the report out. Otherwise, we wouldn't be able to do this. So thank you, Herb. That was a lot of work. And it sounds like it was one of the most difficult studies you ever did, so that was great. We challenged you, so that was good. DARPA hard. DARPA hard report. So at the risk of tooting my own horn and DARPA's horn, but I'll do that a lot in this talk, I want to thank the report's authors for including something meaningful in the preface. According to the preface of the report, the National Academies were surprised to get a request from the Department of Defense asking for guidance about national security-related ethics. Perhaps you didn't know that DARPA is all about surprise. That's what we do. So if it threw you off a little, I'm glad for that. Personally, I've been inspired by the sessions of the last 2 days, and I've learned a heck of a lot, actually. I think the very fact that this symposium came together and attracted the participation it did from academia and from civilian and military technology sectors says a lot about what makes America actually the global leader that it is. Basically, it's all about doing the very best applied research and technology development in the world for our military, and at the same time, as the symposium has emphasized, always remembering the social and ethical context in which we live. By keeping these twin priorities in mind and in balance, I'm certain we can maintain both the military and the moral high ground as we move into the future. Now, in some ways, I'm in a very difficult position here because the ground has been well laid over these last 2 days. I fear that by being placed last in the program, I'm about to live the awful saying, namely that we've come to the point where everything's been said, but not everyone has said it. So I'm here to say it all again. We've heard presentations on the history of conflict and ethics, on some special challenges ahead in synthetic biology, cyber conflict, and unmanned aerial systems, and even some pretty highbrow philosophy, which has been interesting to me. But what I thought I would do to make some of what we've been talking about a little bit more real and concrete is to tell you a little bit about DARPA itself and describe some of our programs we're supporting and look at these as examples of how these kinds of issues sometimes arise in our day-to-day work and how we try to address them really in the real world. In the end, as you will see, our approach is a multi-layered one, incorporating some hard and fast rules, some more general guidance, and in the end, a good dose of common sense, or practical wisdom, all in a combination to achieve our mission. So first, to understand the mission, you need to know a little bit about DARPA, and I wasn't sure everybody here really knows what DARPA is. As I think some of you do know, it's a history that dates back to 1957, when Americans were surprised, terrified actually, to learn that the Soviet Union had launched the world's first satellite, a metallic sphere about the size of a beach ball that was passed over the United States every hour and a half, pinging signals to Earth as if it were mocking us. Congress responded quickly, and by the spring of 1958, so less than a year, the Advanced Research Projects Agency, or ARPA, was up and running. And the mission of preventing and creating technological surprise in the future was given to it. DARPA, as it was named in 1972, had the same basic mission, ever since and has generated a stream of impressive surprises itself over the decades. I think most of you here are familiar with at least some of the more iconic achievements that have were made possible by early pivotal investments made by ARPA and then DARPA. The most famous of which is, of course, the internet, or what was called back in the late 60s, the ARPANET. A computer at UCLA passed the word login to a computer at SRI. They only actually got L and O passed, but it was the first time two computers had talked to each other. Infrared night vision, stealth technology, GPS units that fit in cars, touch screens, and digital voice recognition and translation capabilities all have key roots in early DARPA investments, along with a host of other advances that have made a huge difference for the American warfighter and for Americans everywhere, actually, in homes, hospitals, schools, and workplaces. But DARPA doesn't spend a lot of time looking backward, actually. Today, the nation faces challenges very different than those addressed by earlier generations of DARPA program managers. And here I should take a moment to emphasize that the program manager at DARPA is the key functional unit, as we like to call him or her. They come from academia, industry, government, and elsewhere, and typically come on board for a 3 to 5 year term to solve narrowly focused, pressing problems. And that ticking clock is a big part of DARPA's success, because when you know you have this rare opportunity to achieve something big, something you've always dreamed of trying to do, but that you never thought you'd have the opportunity to tackle. Well, when you're in that situation and you know you have a limited time to accomplish that, you work with like your hair's on fire. And that's what being a DARPA program manager is all about. So we attract these incredible PMs. We have about 100 at any given time. And they take aim at some aspect of the current threat environment that we believe can be mitigated with technology. Now, I said that this threat environment is very different than it used to be. It's always evolving. What does that environment look like today from our standpoint? I want to talk about three things in the environment that we see. First, the United States and those who are devoted to protecting it are faced with unprecedented complexity on a number of levels. No longer are we faced with a single monolithic adversary, as we had during the Cold War, or even a single actual war to make a priority. Instead, we face threats from a variety of nation states, and equally challenging, from an array of diffuse, ever-shifting networks of operatives around the world who use technology to escape attribution for their acts and retribution to our forces. Carol and I were talking, as well as Elizabeth, about the criminal network intertwined with all of this. It's pretty interesting to see, especially in the cyber world. Second, we are faced with the fact that the United States no longer has a monopoly on all advanced technology. We may have absolutely the most advanced technology on our side, but very powerful technologies are available today right off the shelf for anyone who wants them, making it much harder for us to have the kind of advantage we once enjoyed in communications, surveillance, and weapons. And third, of course, we are in a period of serious cost constraint. So while in the past we were able to overcome certain shortcomings with money by outspending our adversaries, that option is not available to us today. That means not only do we have to do things better, we have to do them more efficiently. So how does DARPA help to counter this new reality, especially with technology? We do it by supporting the development of innovative, non-incremental, game-changing new systems, typically involving layers of technologies that together can deliver much more than the sum of their parts. And as we design these approaches, we try whenever we can to invert the cost equation, bringing novel materials and methods of production to bear so we can get these new and enhanced capabilities for less. The products may be weapon systems or comm systems or new ways of protecting warfighters or treating them when they come in harm's way. And the platforms for these breakthroughs can be as small as tiny microelectronic chips or as big as jet fighters or Navy ships. In the end, though, all these technologies are part of a package of ensuring that the United States is the strongest and best protected and most credible global citizen on the block. And as long as you accept that national security is an important ethic. I think we can all agree to that, hopefully. This gets us to the conundrum that's at the core of this symposium, really. Namely, how do we as a nation ensure that we're at the fingertips of the most potent emergent technologies ever devised, and that includes the most lethal and threatening technologies in the world, and at the same time hold ourselves as a society to the highest standards of social and ethical behavior. To be sure, these are strange bedfellows, or they can seem to be. After all, ethics, by a very simple definition I'll give you, are related to what a society is really comfortable with and what a society has settled upon as acceptable and normal behavior. And for the military, let's face it, the military is not about normal behavior. And among Defense Department entities, DARPA is more than others is not normal. So there are issues there. The obvious conclusion here is that there are going to be times when, on its way to exciting technological frontiers, DARPA is going to be the first to reach certain ethical frontiers as well. Certain questions and quandaries that society has not considered very carefully yet. Now, some might argue that this is not DARPA's problem. After all, DARPA is not a policy shop, and it most certainly is not an ethics shop. It is a projects agency that does tech development. It foresees certain strategic or tactical needs and considers how to satisfy those needs with technology. And once it does so, it hands off the technologies it develops to other players, the military services, as one example. And it's not only at that point, and it's only at that point actually, that decisions need to be made about how, when, where, and under what circumstances those technologies should be deployed and used. Arguably, that's when the real ethics questions actually come into play, how you're going to actually use the technology. Nonetheless, the case I'd like to make today is that DARPA does have a responsibility to recognize and weigh ethical issues right up front when it comes upon us in our explorations of technological frontiers, and is actually quite well positioned, prepared, and indeed inclined, actually, to do the right thing when, in the course of its work, these kinds of issues arise. And to demonstrate how that happens, I'd like to give you three concrete examples and dive into three areas that have been actually talked about already, but really tell you what we're doing in those areas and how we deal with some of the ethical concerns and issues. The first area is privacy, which is a huge area now, of course. Legal scholars tell us that nowhere in the Constitution is there spelled out an explicit right to privacy, but a series of court decisions over the decades have recognized such a right to varying degrees. It's hard to imagine a more deep-seated trait of American culture than the presumed right to be left alone. So there's a very strong presumption of privacy in the American mindset, one that ethically we should not violate without careful consideration. But new technologies and social trends are running up hard against this assumption and tradition of privacy. First, Moore's law and the fast-growing capacity of digital networks have led to a huge explosion of information, much of it containing personal details. Consider that about 90% of the data stored around the world today, so 90% of the data stored around the world today was generated in just the last 2 years. That's like all the data in the world. Nearly 600 new websites are being created and launched every minute of every day. And this is the one that kills me. And about 48 hours of YouTube videos are uploaded to the web every minute. 48 hours of YouTube videos are uploaded to the web every minute. Now, admittedly, that's a lot of funny cat videos. But of course, it's not a lot of it's a lot of other information too, about people, including information many would consider private. So there's all this information out there, and on top of that, there are these new big data analytical tools and today's enormous computational capacities that together are making it possible for the first time not only to gather obvious truths, as in he posted 300 funny cat videos last year, so he owns a cat, but also hidden truths, as in no videos, but he bought 15 lint removers last year and a tube of hairball medicine, so he must own a cat. DARPA has a number of programs that have accelerated our capacity to make sense of huge data sets, and so it has brushed up against privacy issues in a number of ways. Clearly, there needs to be some rules of the road here that are on par with the new technologies. And as everyone is aware, there's a process underway under the direction of the President to reconsider what some of those rules should be in various circumstances, including the kinds of protections people should be able to expect when it comes to their phone calls or emails or the drones outside their windows. Whether those drones are being flown by hobbyists or the police department or Jeff Bezos. At DARPA, in addition, of course, to complying with any laws that may be relevant, we consider these issues explicitly and individually every time a new program or a project is pitched, and throughout the stages of the project's lifespan. We have decided not to execute certain programs because of privacy. At times, we ask experts from outside DARPA to help us think through some of the privacy or other ethics issues raised by prospective projects. But we take the responsibility to make the decision, and we put that on ourselves squarely. We recognize that public trust is our most important asset. It is something we have built over decades of envelope-pushing work and value it enormously. What I'd like to remind you, though, of is that there's also a substantial ethical argument for maintaining or even expanding these information collection and analysis capabilities in some areas, and I'd like to talk about some of those. Consider, for example, the challenge that our forces in Afghanistan faced as they tried to determine which areas posed some of the greatest risks and where in the country they could count on support. Traditional intelligence methods focus largely on locating high-profile warlords and other bad guys, in part on the assumption that the populace in those areas would be among the most antagonistic and dangerous to U.S. forces. But that was a view that didn't give proper weight to the reality on the ground and the community dynamics that existed there. A DARPA program called Nexus 7 worked to examine data on everyday activities of large numbers of people in various areas of Afghanistan to get more honest signals of the political and strategic situation on the ground, minimizing the chances that our troops would take actions that would inadvertently set back our ambitions for positive change in key areas, and that it did save people's lives. A related big data program called X-Data speeded up the development of software tools to help warfighters make smart, strategic decisions, whether standing around a planning table or in real time while out on patrol. A third program I'll mention is called ATOMS. We love our acronyms at DARPA. ATOMS stands for Anomaly Detection at Multiple Scales, which aims to detect and flag significant changes in an individual's behavior. Changes that suggest an increased risk that the person may be suffering from unusual stress or duress of the kind that might trigger, say, an extremely violent reaction or outburst. Tools like ATOMS could, in theory, help prevent some of the seemingly random violence that we've seen in our society, especially in military bases or in other settings. Let me be clear, though, in all these cases, there remain difficult privacy and other ethics challenges, including the very important challenge of getting the right balance of sensitivity versus specificity. That is, can you tune these approaches so that you can detect as many dangerously disturbed people as you can without wrongly sweeping others up in the process? In other words, what level of accuracy and precision should we as a society demand if we're going to use these tools? And what methods of validation should back up those assertions of accuracy and precision before these technologies are actually deployed? Even if they are accurate and precise, do we have effective methods of intervention to reduce the risk posed by identified individuals? And if we don't, then what value is there to identifying them in the first place? These are not questions for DARPA to answer, but I believe they are questions that DARPA should be aware of and foresee as it makes decisions to pursue some of these technologies and capabilities. In fact, I would argue whenever possible, DARPA has a responsibility to generate solid efficacy data as it performs its work to inform, in an evidence-based way, the policymakers and others who will ultimately decide if these tools are used. There's another program at DARPA I'd like to mention here in this big data analytics space as well. The program is called MEMX, and it involves analyzing large amounts of public information. So this is information people have put on the internet themselves, mostly derived from ads that people have placed and that appear to be linked to human trafficking and other illegal activity. We've shown that by cross-linking this publicly available data, basically developing tools that can search the deep web, so places on the web that Google will not take you. We've shown that cross-linking this publicly available information with other databases of criminal activity, we can actually start to draw up maps that show previously invisible connections between different pockets of illicit activity around the world. Connections that can be extremely helpful to law enforcement and can help shut down a global scourge like human trafficking. So big data analytics are essential for this process of connecting the dots, certainly in the criminal and law enforcement sector, and is absolutely needed if we are to fight on par with these individuals and groups, networks of criminal activity ongoing in our world. The second area I'd like to talk about that DARPA is working in is biological engineering. Some of you may be aware that earlier this month, DARPA made a rather significant announcement. We set up a biological technologies office, and we don't create new offices very often. This new division, the Biological Technologies Office, is going to focus on opportunities at the intersection of the life sciences, engineering, and computer science. Now, we're not naive as we made this decision. We knew that any time you talk about manipulating life or organisms in a laboratory, as is the case with some of the work we're going to be doing in synthetic biology, you're going to raise fears and hit some ethical speed bumps. And as predicted, Twitter lit up when we made our announcement. DARPA's new biotech division wants to create a transhuman. DARPA is going to start messing around with biology. DARPA's new biotech unit will try to create new life forms and brain-controlled drones. Inside the military's new Office of Cyborgs, and getting ready to microchip the entire human race. Okay, some of that's true. No, just kidding. Still, let me tell you what really motivates us here. For one thing, the military feels a strong commitment, an ethical commitment, actually, I'd say, to provide the best care to our wounded warriors, too many of whom have lost limbs in our recent wars in Iraq and Afghanistan. So we're helping to develop a new generation of prosthetics that can be controlled by thought, yes, controlled by your brain, and that may even be able to send sensory information back up to the brain so a person can not only manipulate things in the world, but again, have a sense of feel, a sense of touch in a very natural way, same way you and I have that. So I want to show you a video here, and some of you may have seen this. This was on 60 Minutes back in December, actually. Part of the program, we had a Revolutionizing prosthetics program that developed an arm that could be controlled Wi-Fi through moving your foot movements and move this arm sort of mechanically. The second part of the program was to actually see if you could attach an implant to a person's motor cortex and have the person, through thinking about it, control a prosthetic. And we did a lot of work in monkeys over the years to look and see if this was possible. And Jan, who is the subject here, is a quadriplegic, so she's paralyzed from the neck down, cannot move her arms or legs. Courageously volunteered to be a subject in this investigation, and I sort of cry every time I see the video, just based on her courage to go ahead and do this. So,
5 months after the surgery, we came back to see whether she would be able to control the robotic arm with nothing but her thoughts. They plugged her brain into the computer, and this is what we saw.
I can move it up and straight down and left and right and diagonally. I can close it and open it, and I can go forward and back.
That is just the most astounding thing I've ever seen. Can we shake hands?
Sure.
No, really.
Yeah.
Like, come right over here.
Yes, you can over
Okay.
there.
concentrate?
No, it was hard work getting there. I struggled greatly to go up and down, getting them up and down is so easy, I didn't even think about it, side to side. I didn't think about it.
Just like
Just like,
your arms used to.
yes.
So, further, as we create these brain-machine interfaces for use with prosthetic devices, we'd like to apply what we're learning about the brain to solve other problems that can give our warfighters the best chance of staying safe and coming home alive. Everything from designing visual screen displays that present information in ways that are easiest for the brain to process and understand, to new treatments for traumatic brain injury and PTSD and memory loss and depression. So we're not quite sure where this is leading, but we know we're on the edge of something here, and there are lots of possibilities as we learn more about the brain and how it works to treat, especially our warfighters, as they come back with these diseases, but also the American public at large. So in short, this work and a lot of the work we do has a great potential to relieve human suffering, not only in affected military personnel, but for millions of civilians whose lives are affected by these and other debilitating conditions. Obviously, you can think of bad ways to use this technology as well, so there are issues there. Let me give you a few examples of neuroscience programs beyond this one that could arguably raise concerns about possible unethical applications, but that I believe deserve support because they do have great humanitarian potential. Two related programs in the category are known as REMIND and RAM, and actually Bob mentioned this on his talk. REMIND, which stands for Restorative Encoding Memory Integration Neural Device, was born in response to a large number of U.S. service members returning from Iraq and Afghanistan with memory problems caused by traumatic brain injury. Scientists are only beginning to get a handle on the dynamics of how blasts can lead to TBI and affect memory. So REMIND involved basic studies on rats, actually to model how short-term memory is encoded and potentially restored in the brain. Positive results from REMIND have paved the way to another program called Restoring Active Memory, or RAM, which aims to develop what might be thought of as a memory prosthesis, an implantable neural device to help restore what is known as declarative memory, which is the kind of knowledge that can be consciously recalled, including events, times, and places. So imagine helping a brain-injured soldier remember once again memories of a lost one that seemed to have been lost forever, but lost only because a small neural connection in the brain had been harmed and can now be restored. Think about the profound suffering that can accompany severe memory loss and the sense of wholeness that could come where you regain that capacity and those seemingly lost memories. Now, you don't have to be a professional science fiction writer or movie producer to imagine some potentially dark applications of some of this stuff. Say Tom Cruise bedeviled by vivid implanted memories of doing things he had never done. But it is DARPA's mission to pursue these kinds of frontiers when they have solid potential to help our troops, and perhaps even people with other memory deficit disorders like Alzheimer's. So we're moving forward with these projects in full compliance with every applicable scientific and ethical consideration. And we have high hopes of making a difference for people with real needs and their families. Another DARPA neuroscience program is called Subnets, for systems-based neurotechnology for emerging therapies, and aims to build on the current use of deep brain electrical stimulation. I didn't know this when the program was pitched, but there are over 100,000 people walking around with brain implants. As you may know, this kind of brain stimulation has proven effective for reducing the symptoms of some neurological disorders, but doctors and scientists know very little about how it actually works. And so have been reduced to trial and error as they try and find ways to use it to help people with service-related issues, such as post-traumatic stress disorder, major depression, and chronic pain. Subnets aims to develop a neuroprosthetic device for neuropsychiatric illness and more precision and knowledge of brain systems. So does the prospect of implantable, customized brain stimulation devices that make people feel better begin to blur that line between man and machine and raise issues of where the line should be drawn between relieving suffering and just enhancing mood? Perhaps, but it also holds out hope for a vastly improved quality of life for afflicted veterans who have sacrificed for their country. And it's DARPA's job to explore that challenging but not impossible prospect. Beyond the brain research that will fall under the new BTO, or Biological Technologies Office, we also intend to accelerate our work, as I mentioned, in synthetic biology, a field that involves genetic manipulation of cells to take advantage of their processing capacities. We covered some of this ground yesterday in a great talk, but imagine cells or organisms designed to produce new materials with novel electronic, mechanical, or optical properties that just cannot be made by conventional chemistries in the laboratory. Or cells that can alert us when some new bioterror agent or toxin passes by. Or new bio-based diagnostics that tell you instantly what bug you're infected with. Or novel vaccines that take effect immediately instead of taking weeks or months to kick in. All these are on the agenda, and all are moving forward in some of our Engineering Living Foundries, the Engineering Living Foundries program. Is this wrong? Is there a limit to how much we should manipulate living organisms? Does rewiring the brain to allow someone to move an artificial arm amount to an unethical degree of hubris? If that's okay, what about rewiring the brain to make someone more comfortable in a stressful situation? What if the goal is to make them more comfortable in the stressful situation on the battlefield so that they can aim their weapon better? And what if you add a drug that removes the memory of that firefight so they are not bothered by any guilt? We take all these questions seriously at DARPA, even though we sit at the very earliest stages of some of this research. We're not quite sure where some of this is headed, just to be honest with you. I mean, you get to a point where you see you can do certain things and imagine future possibilities, but not sure where it's going. As some of you know, one way we deal with this, and I said at the beginning, the program manager is always the key functional unit and always the person responsible. But one way we deal with this is we have created 2 expert panels in the past year alone. One focused on neuroscience issues and one on synthetic biology, to discuss as needed the ethical, legal, and societal implications raised by these emerging technologies. We try and bring in people on those panels that represent a wide range of views, ethicists, philosophers, legal scholars, etc. We don't feel like we can answer these questions ourselves as technologists. We need a diverse set of expertise. We also have guidance on synthetic biology, and some of this was talked about yesterday, but we also have some guidance provided by the Presidential Commission on the Study of Bioethical Issues that was released in 2010. And HHS last year requiring new levels of oversight for research involving the genetic manipulation of certain microbes and toxins. So guidance is forthcoming, but it's often behind the technology, as we've seen over the last 2 days. So we have some confidence that with this combination of hard and soft controls, we can safely develop the platforms we're interested in creating without drifting across ethical boundaries. The third area I want to mention, and the final area, is autonomy. And we talked a little bit about this earlier in the case of unmanned aerial drones or vehicles. It should not be surprising that DARPA's emphasis on robotics, one of the concerns, it should not be a surprise that DARPA is focused on robotics, but one of the concerns we hear from people is that autonomous machines will take over, especially ones that are armed to the teeth, like the Terminator. First, just to set the record straight, I want you all to know that autonomous ground-based humanoid robots are not around the corner anytime soon. In fact, if you had come to the DARPA Robotics Challenge, which was held last December in Florida, we had some of the most sophisticated human activity robots in the world that have been developed, and they competed to accomplish routine emergency help tasks like attaching a fire hose or opening a door. Much of this challenge was actually motivated by the Fukushima disaster, and so the thinking was they couldn't get humans in right away because of the radiation environment. Let's develop some humanoid robots that can work in a human environment and be able to send them in a natural disaster type scenario to turn valves, close doors, connect fire hoses, et cetera. So we walked them through a series of 8 different scenarios. One was to climb a ladder, which ended up being a series of steps, which is the picture you see there of the Atlas robot staring at the ladder for 10 minutes before he put 1 foot on the ladder. So as the challenge program manager, Gil Pratt, told one reporter, if you look at the heads of these robots, those that even have heads, you will see that for the most part there is nothing at all in them. If you tell one to climb some stairs, the first thing it will do is look at the stairs for about 10 minutes. Believe me, you don't need to worry. But of course, I have to add the caveat of not yet, right? Because the technology is certainly moving in the direction of greater autonomy. And we know that in other realms, including the stock market computers and some unmanned and unarmed drones, degrees of autonomy are increasing. It turns out autonomous walking is the hardest. Autonomous ground robotics is the hardest area. The Air Force had it easy with unmanned aerial drones, pretty benign environment in the air. The Navy has it a bit easier. The Army is really, they have it tough, trying to design ground robots. But here it's important to know that not only do we have the benefit of soft guidance or on-call ethicists as we decide where it's appropriate to draw the line on autonomous behavior, we have the Department of Defense policy as well. In 2012, a directive was signed by DoD that spells out in detail the rules of engagement regarding autonomous warfighting systems. I won't go into detail, and it's fairly high level, but it essentially says that it makes plain that autonomous and semi-autonomous weapon systems must be designed so that commanders and operators are in the loop, exercising appropriate levels of human judgment and decision-making, not only over the use of force, but also to prevent loss of control to others. That kind of policy, on top of other existing laws of war, treaties, weapon system safety rules, and various rules of engagement, help make clear that the boundaries of ethical conduct, and when to use autonomous systems in a warfighting domain. I don't want to pretend that this is a settled area by any means. It's not. Technology in this domain is constantly changing, and our legal and ethical considerations are going to have to change as well in order to keep up. And we will do that with the full spectrum of frameworks available to us, from hard and fast laws and regulations to departmental or agency policies to inform guidance provided by experts at DARPA and outside the community, and also with the least well-defined but perhaps most important safety mechanism of all, and one that I've mentioned briefly, the judgment calls that we as individuals make every day. You should know that every new project proposed at DARPA must pass muster with an internal review panel. We call it the Tech Council. That considers a broad list of questions as a program manager comes up to brief their new program. Tough questions are posed, designed specifically to unearth any underlying technical, policy, or the ethics issue. I happen to believe that this conscientious process of asking the right questions and pressing for honest answers is as crucial as any other part of our ethics efforts. And in fact, the National Academy's report recognizes this pretty explicitly in its recommendations, which can, in a large part, be translated to say, ask the right questions early and often. So let me end with a story that I think makes this point well, of how important it can be to ask the right questions if you want the right answer. It's the story of 2 monks at a monastery, and I thought it was appropriate for Notre Dame. Story of 2 monks at a monastery, where the sole focus is supposed to be on meditation. One monk approaches the abbot and asks, "Is it okay if I smoke a cigarette while I'm meditating?" And the abbot, seeing the addition of a cigarette as a distraction, growls in reply, "No, just keep meditating." A few minutes later, the monk looks around and sees another monk smoking while meditating. And when he tells this smoking monk that the abbot had refused to let him do so, the smoking monk asks, "What question did you ask the abbot?" "I asked him if it was okay to smoke while I meditated." Well, there's your mistake, the smoking monk says. I asked him if it was okay if I meditate while I smoked. And he said, of course you should meditate whenever you can. So it's a funny way of ending the talk, but it really just tries to make my point that it's important for the right people in the right positions to ask the right questions. And to have that atmosphere at whatever organization you're at that allows for that discussion to happen in an open and honest way. We're trying to do that at DARPA. So let's all keep asking the right questions, and I'm sure that as a nation we'll get this thing right. Thank you.